Can you all see my screen?
Yes.
Excellent. I have a very strange aspect ratio for my screen, so it might... Brilliant. Thanks, first of all, for inviting me to have this talk. It's good to see some familiar faces from the past and some new ones. So it's good to see QGIS growing in US. Just a bit of background. We are a consultancy and software development company based in UK and Slovakia. We have contributed to QGIS since 2013 and mostly around 3D QGIS point clouds, new data provider like Mesh. In addition to that, we have also private plugins developed for clients. We help people to migrate to open source if they wish to, and we do support and training in open source GIS as well. We also have a mobile data collection, as Randy mentioned, based on QGIS for using it in the field for collecting data using your mobile sensor and synchronization system behind it. I thought I'd go through Point Cloud and some other data providers, but Point Cloud is quite an extensive subject. So with the recent developments, I'll try to squeeze in just the point cloud features in QGIS, and if there is time, I can show you some of the 3D data providers we have recently added in QGIS 4. And so what's point cloud? Point clouds are data that are captured in forms of point. It can be an aerial survey or it can be a terrestrial survey. These data usually are in large volume, like millions, sometimes billions of points, and they represent different types of information from classification to the elevation, etc. And usually it's stored in a format like LAS. They are not indexed, but you can make them indexed, and it will be easier to stream the data for software which supports it. So it's kind of spatial indexing, and it knows what part of the data to look at when you deal with visualization or processing of the data. So we had QGIS, and prior to that, there were some plugins and some ad hoc solutions to load LIDAR data, but it wasn't a proper data provider. You couldn't do much with it. It relied on external tools, and QGIS is as always has been a very flexible and powerful tool for spatial data management, good cartography, advanced geospatial analysis tools, and very flexible in terms of extending it through plugin, and also it's free and open source. So back in, I think, 2020, we thought it would be good to bring point cloud LIDAR data directly into QGIS. There was already a good library developed by our friends Hobu, not far from you, and PDAL, which already has got the basis for reading and processing the data. So we ran a crowdfunding in collaboration with Hobu and North Road in 2020, and brought the PDAL reading and indexing and writing, indexing and visualizing functionality into QGIS. So that was the first crowdfunding. Then we ran subsequent crowdfunding again in collaboration with those friends and added more features. In addition, we have been contracted by several national mapping agencies to add various functionalities, which I'll go through shortly. So the first step was to bring the just reading the data. Usually point cloud data comes in LAS format, which is compressed LAS, and data are not indexed, so it takes a long time to load. What we did in the first release, we added PDAL as another dependency to QGIS, so it indexes the data. I think the first one was an EPT format, but then moved to COPSI. So it's like a cloud optimized format where data are indexed properly, and then you can visualize it and work with it in a much smoother and faster way. As I said, point cloud data, we are talking about millions or billions of data. So it's like the first step to make sure that data are indexed properly. And in the first release of point cloud support, you could see the data, the classifications. If the data were classified, you could also see the attributes of it, like elevation or intensity. So it was, again, another data provider like raster or vectors, and you could change the style, embed it in your QGIS project, and became like a normal layer in QGIS. Then if it has, your data has RGB, you can visualize the image of it, both in 2D and 3D. In addition to that, we had some effects to see it better, like eye doming or shadows, or this is in 2D, this one was in 3D. We have also ambient occlusion, then some ordering of the data so you can see it properly and ordered from top to bottom or bottom to top. Also, it gives you flexible symbology. You can show the classification, hide or unhide the specific classification, see the percentage of the points that belong to that class. You can change also the size of each point, how you want to see, how big you want to see those points representation. You also have the filtering functionality. You can create some similar to vector data, a filter on the data source. So you can filter, for example, in this only for the ground data where it's above the elevation is above 200 or below 250. Actually, this one is obsolete now because you have got a vertical controller in QGIS, so that one you can do it dynamically on the screen. And then the 3D symbology, you can follow the 2D, so you can have the same map view of 2D and 3D. You can also have it separately. You can disconnect it and apply different styling in 3D. Also, you can, in 2D and 3D, you can render the data as surface. So instead of scattered points, it creates some triangulations, and you can control how, if there are some odd triangles, to remove that. So it gives you a smooth surface. You might see some holes because there were some odd triangulation, but generally it's a nice way of seeing the data without converting it to raster and doing any interpolation. So these are all done live on your screen. You can also export the data. Some people still love shapefile or DXF, and they don't, their software, other software for interoperability, they don't support LAS or COP-C, so you can select a subsection of data or filter data to another format, OGR format. Again, 2D rendering, you can do the same as 3D, convert it to represent your points as a surface through live triangulation on the screen. And then the major work we did again with Hobu, they introduced cloud optimized point cloud. So with cloud optimized point cloud, you can store your index and store your data to a large file and stream this data either locally or through a hosted service, and then you can just point QGIS to view this data. I quickly show you probably on my screen how it looks like. So this is LoLA, which is the LIDAR data derived from all the lunar missions. And you can just add it as this COP-C file through a HTTP protocol remotely, and then you can visualize it directly in QGIS 2D or 3D. As you can see, the moon is not made up of cheese, so it's just points. So it's a very nice format, and it's used also for USGS to provide most of the data, I think, either EPT or COP-C format. And the good thing about it is backward compatible. So if you have a software which works with LAS file, you can still give that LAS file directly, the COP-C file to the, that software. Yeah, that's you can pretty much point your browser to a remote COP-C, EPT, or another format which I'll quickly talk about shortly is a virtual point cloud. You can just point it to a remote URL and it will render your data and fetch your data. So I don't know how many billions of points that one was, but you can see you don't need to download the data and put together hundreds of tiles, etc. It's just one file, you point QGIS to it, and then it gets rendered and you can work with it. After the visualization, we had some requests from community to add processing. PDAL has got lots of powerful processing tools. Usually it's not as easy as GDAL. It requires compiling by hand, or these days probably by AI, pipelines to do things, and it's not like a desktop application with people would do it on QGIS and write those pipeline manually. So what we did, we wrapped these some of the more useful functions from those pipelines through PDAL range, and then use those as processing algorithms in QGIS. So you don't need to write JSON pipelines or handling the parallelization of the tasks, etc. It's all done directly through under the hood PDAL range, and then from graphical QGIS processing tool. So if, for example, you go to QGIS 4 and expand your point cloud processing toolbox, you will see a whole bunch of algorithms that you can run to do various things. I go through some of them. The basic one, clip by polygon. So you have a polygon, you can clip your point clouds and output it as a new file. You can create the density from your point cloud. You can do filter by expression. It's pretty much the same you would do for visualization, but this one, it outputs it as a new file. And the filter by expression, most of the algorithms do have on their advanced filtering option. So let's say you have got a point cloud data which are classified and you want to rasterize it. Instead of doing rasterization on all points, you can select under the advanced part to filter the data and work only on the ground data. So the result will be the DTM. You don't need to worry about all other features. Extract by boundary. So it creates a boundary around your classes. Convert to raster. So this is just direct conversion to from point cloud scattered points to raster. Then there is another one, convert to raster through IDW. That one takes a bit of time, but it does some interpolation. And then the one that recently we have added, again in collaboration with Hobu, which is point comparisons of point clouds, which is, it appears as one processing tool, but quite a lot of work behind the scene went for this algorithm. Imagine you want to compare for landslides or erosions. You have got regular survey, let's say, of coastal area, and you want to do comparison of point clouds. There is one method, D2D, you convert it to raster, interpolate the data. So you create two rasters from the point cloud and then compare the two rasters of the elevation to see the landslide, erosion, or earthquake movements or things like that. But this one, for areas where you have got very vertical like cliffs and areas like that, when you convert it to raster, it loses all the valuable information you have. And there is a standard way of doing it. There are lots of paper on this method, multi-directional something, M3C2. So it creates like a cylinder and calculates the normals, how the points have moved between two temporal survey. And then based on that, it calculates a new point cloud where you can see the distance of travel along those normals, and it gives you certainty as well. This method allows you to, if let's say you have a very old LIDAR survey with not good quality data, very low resolution, if you convert it to raster, the result will be not so good, but with this method, still you can get some okayish result. And then based on that, you can, this one actually, I'm writing a blog post, I can show you the screenshots here. So yeah, this one, it's an earthquake in Japan in 2016. This is post and this is pre survey. Interestingly enough, just a week before the earthquake, they had a survey. So they must have known something would happen. But by comparing those two, you can see all the buildings that were destroyed. There was a landslide. It wasn't within that survey, but with this method, it creates this point cloud, and as I said, you will see different class. It adds this distance and also the certainty level, how certain the algorithm has calculated those distances. So it's not one raw result like raster to raster comparison. As I said, there will be a blog post. You'll keep an eye on it, and if it's of your interest, you'll be able to read more about it. And another algorithm we have recently added for QGIS 4 is noise filtering. So basically in QGIS 4, we went back and thought about what would be the workflow for a raw LIDAR survey to, let's say, DTM. And we tried to create those modules, algorithms, so you can smoothly fly your drone, georectify your survey, clear the noise with this. As you can see, there are some noise on top. With this algorithm, it removes it. Then it does the classification between ground and non-ground. That's the very basic one you probably need. And then you can also calculate height above ground. It's something you can easily run this, and on the left you can see the shape of the ground, but this one is just a flat ground and the trees and buildings on top of it. So it gives you the height above ground. The ground will be 0 and everything else will be above or below it. There are other algorithms as well for thinning, exporting it as vector layers, merging data, tiling data, converting it between different formats, getting information, and reproject, transform, or georectify or fix the projection. So through this work we have done, we also introduced a new format inspired by virtual raster. We introduced virtual point clouds. Virtual point clouds, usually point cloud surveys come in blocks of, I don't know, 1 kilometer by 1 kilometer. And when you want to work with them, you have got hundreds of tiles for an area, and it's very difficult to manage them one by one. So with this virtual point cloud, you get a single JSON file, which is compliant with the Stack API. So it's you can use it like a Stack item and directly put it in your collection catalog to publish it. And then within that, you have reference all the local files, and it will be treated as one single layer in QGIS. So if you want to do processing, clip it, edit, do other things with it, it's just one file. And in QGIS 4, we have also, I don't know, it's 4 or 4.2. We also added editing of the VPC file, creating the overview by thinning them, creating the label. So those kind of things are also added in the recent QGIS versions. With this, you don't need to, you can see individual tiles, but yeah, with a very large area, you will be able to smoothly pan and view the data. So this one was, I think it was a video, and I probably couldn't get it working, but it's 37 billion points within that. Yeah, if you are working with the latest QGIS, you should be able to create overviews of VPC and also editing it. And the other thing in the latest QGIS is the remote serving of the data. So if you have a VPC which links multiple COPC file, you can just get the link to that VPC and point it to QGIS. Sorry, is there a question? I heard somebody. Limit a number of tiles in VPC. I think I have seen an issue, but probably it's related to operating system that when you run the algorithm in QGIS, it doesn't, in Windows, it can't go above 1000, but technically it shouldn't be a limit. Okay. And this last section, point cloud editing, the usual workflow for point cloud survey, LIDAR survey, you survey the data and run some tools to classify it. This classification might not capture all the reality, so you want to edit the data. What we introduced in QGIS 4.4 or 4.2 is to edit the data directly in QGIS. So with those, you can change the classes. It doesn't move the data along XYZ coordinates. It only changes the classes, and then you will be able to save those edits. You have got full undo redo support, and you can do apply the filter expression you want, so you can select the data you want to edit on the 3D map canvas, then draw a polygon within the 3D map view and apply the class to it, or use a paintbrush. If you work with Photoshop or GIMP, you just draw the paintbrush and it will apply the class to the whole points that it touches. And then you can draw a line above or below, and it will apply the value you want. The best way to see how it works, it's my colleague's live demo of it, and also there is a blog post we have. A bit difficult to explain how these tools work, but yeah, you can. And as a result of this, we also added in this GIF, you can see it, this 3D cross-section tool, which makes it much nicer to slice the data, then select what you want to edit here, and select by paintbrush like this, and it will edit the data and apply the new classes. So the end result is like this piece of road was missing viaduct, and you can see that by editing it, we have applied a new class here. Okay, I think that's all I had to talk about. But if you have any questions, there was already one question. If I managed to answer, if there is any other, feel free to ask, and we can discuss further. We have plenty of time. Go ahead, Doc.
Yeah, I was just going to mention that when you first came out with the VPC stuff, I did run into a limit of about 800 tiles on Windows, and it turned out it was related to the length of the file names of the LAZ files. I guess at the original iteration, it was passing the name into a command string, and you just ran into the hard limit for the Windows command string.
Yeah. Yeah, as I remember seeing that issue. It was probably something to do with the operating system.
Yeah, it worked better on Linux because it had a longer command line space.
Yeah.
But I think that was addressed later on. I just haven't had a chance to follow up on it.
Brilliant. Yeah, I remember that ticket. Excellent.
Great, great tools. I've been using them for working with point clouds, and I especially love the improvements in being able to do GPS time as a raster, so I can just quickly see for a reservoir how many days, specific days that were the collection was done in, so I could relate that to the gauge for that reservoir and see if I can do an automatic analysis of the water height.
Yeah, you have got the option to reclassify, to show the attributes based on various information, GPS time. Yeah, this one, it just shows you how they flew the drone or airplane.
That's just awesome. Thank you.
No problem. Any other questions? I keep my screen sharing, but yeah, if you have any question, I can live demo something.
Do you have any plans in the future to add coordinate editing? Say if they were trying to sync two swaths of LIDAR so that they would be...
We thought about it, and it's a very complicated workflow because, as I mentioned, these COPC files are indexed. So the X, Y, Z are kind of fixed, and Z, it's something we might do something about it, but X and Y, it's very difficult, because if you have a large data COPC file and you edit move the points, then you will end up re-indexing the whole file. And if you have a large file, I don't know if you have come across it, and it's not indexed, you drag and drop it as LAS in QGIS. Sometimes it takes a minute or so to index the file. So it becomes very unuser-friendly to move the data. We need to think about some ways of addressing it.
Would that be something that might be better addressed as a VPC of straight LAZ files, and then output as a COPC as the final product?
Yeah, or having it some sort of memory layer, and then keep changing those points, and then at the very end, when user presses saves or ends the session, patch the file. We haven't come up with a good solution, but usually the editing so far we have been dealing with is to deal with the classification, to fix the classification. But elevation is definitely another thing to get rid of water bodies or reflective surfaces that you want to change the elevation or apply a new elevation to that.
Have you thought of just, along with the convert to raster, I know you do the IDW interpolation now.
Yeah.
Have you thought about just adding an option to just give the mean ground or median ground within that each cell, as opposed to interpolating, so that people see just where the data is?
I thought this one, point cloud to raster, does part of it as well. I haven't tested it for that specific, but worth looking at this. It does some averaging as well. So you select the cell size, and then within that.
So for one of my workflows, I specifically have to have the mean ground, and I do an interpolation, partial IDW interpolation, before I do fitting for water body surface elevations. And that's just something that
if it's a small amount of data, what you can do, you can just export those as point vector data and then use vector to raster. There are more advanced tools to do those kind of things.
Well, remember that 800 tile?
Okay.
That was about a quarter of the lake I was working with.
Excellent. Any other questions? Anything? A couple of new formats we have added for QGIS 4 while we are here. It's the I3W. I don't know if you are familiar with Esri scene layers, which is equivalent of 3D tiles, but it's another standard. And you can add your data from Esri's server, which has this I3 as the layer directly in QGIS and visualize it in 2D and 3D. It supports also the texture surfaces as well. And then 3D tiles has been around for a while. We added it, Cesium funded that. So that one was way back. Not where it is, but anyway, it should be somewhere here. And there is also globe view, which you can see things in a globe mode. Not all data formats are supported, but point cloud and 3D tiles and I3S layers are supported in globe mode. Brilliant. I stop sharing. And for future, we have got some plans. The thing that QGIS looks like lacking at the moment, and we have tried to get some funding unsuccessfully, but if somebody has got deep pocket with a connection, we are trying to get Gaussian splatting support in QGIS. My colleague has prepared the proposal. So if you are interested in this data format to be incorporated in QGIS, just drop us a line.
Which is the way a lot of this happens. For those of you unfamiliar with QGIS fundraising, it's not quite a GoFundMe, but it's pretty close to that. Like, you come up with a problem, throw money at it, and get a solution out of it. Which I remember doing all the LIDAR, the stuff with Hobu. That was what, 5-6 years ago, when you crowdsourced all the LIDAR.
That's correct. Yeah.
Yeah, tools into QGIS. So.
And cool. I'll share the presentation with Randy, so you can share it with you. He has got also my contact details. If you have any questions, follow-up query or anything, feel free to contact me directly. But yeah, again, thanks for inviting me and listening to my presentation.
Oh no, thanks for doing that. It helps out a lot here because, like I said, it's a growing group, but we broke the number of people we had last month by 1, so we're getting there. It's getting better.
Good, excellent.
Yeah, cool.
Brilliant. Excellent.
So,
yeah, have a good luck with the future one, and I'm happy to come again and present some of the future work, depending how things go. But yeah, there is quite a lot of work under the development.
Awesome. Well, thanks, man. Thank you very much for coming. And we hopefully have this recorded. I am relying on the good graces of Doug, Doug's recording studio over in North Carolina to do that. And I'll try to get it pushed up as soon as I can to YouTube and add some more stuff to the website. So the work continues.
Brilliant. And good luck with your user group. It looks to have become very activated in the past year or so. So well done.
Yeah, we're getting there. It was active, then died, and then go back to active again. So maybe at some point we'll have money to throw at some problems.
That would be the preferred method rather than just leeching.
Oh yeah. That's the plan. I got a plan.
All
I'm
right.
working on it. But awesome. Okay, well I guess that's it. So thanks, Saber. Have a good afternoon, evening. I guess it's about 6 o'clock there.
7. I'm in Rome, Italy, so I'm 1 hour ahead of British summertime.
Oh, okay. You're further along than I thought. Well, cool.
Yeah.
Something fun and
Thanks, everyone, and enjoy the rest of the day. It was a pleasure.
Thank you.
Thank you.
Have a great day.
Bye.
Bye. Thank you.